Hello, and welcome to Group 13's Go Baby Go midterm demo. We are a team full of four computer engineering students, and we will be giving our progress update on our senior design project. So, just for a quick recap, Go Baby Go is a national community based research design and outreach program that provides accessible, inexpensive, and common sense solutions for individuals with limited mobility. One of these solutions is a modified ride on car that drastically impacts children's lives by providing them with the ability to move more independently. And these modified Power Wheel cars can lack a lot of essential features, and previous Go Baby Go car users have noted that it can be difficult for the parent and children to use. So Go Baby Go gave us a few requirements with our senior design project. They wanted the Go Baby Go car to have an alternative steering mechanism, a remote control steering option for the parents, augmentative communication, collision sensors, zero radius turns, um, to be able to record data for their program, and proper documentation in order to modify future cars. This is sort of our system block diagram where we have blocked out the different hardware slash software requirements. In the middle, you see we have a processor that sends signals to the motor, steering system, and the distance detection sensor. This is all powered through the car battery and the DC power source. We also have a Bluetooth connection that's connected to the parents application that's able to also control the car as well.
This is our current PCB design. Our main microcontroller is the Atmega 328PB. The bottom two integrated circuits are Texas Instruments H-bridge drivers, the DRV 8841s. They receive logical input from a microcontroller to control two sets of motors for moving the car. The empty section at the top right is our HM10 Bluetooth module. The Bluetooth module will communicate with the Atmega over a serial interface. The several pins along the top are for connecting our sensors and joysticks. In our final product, these pins along the top will be removed, and the wires for these will be soldered directly to the board to prevent them from separating when the car is in use. One design change we may also consider is in the future moving the components closer together and reducing the overall size of the board. The components were spaced out like this to make soldering the small surface mount devices easier, but currently it's not needed. There are several improvements that we want to make to the PCB. The first one is the removal of the top ground plane. We originally added this to help disperse power over the top and bottom plane, but it proved to be more of a hindrance as some of the power lines would arc to ground when supplied 24 volts in the batteries. Almost all of our ground lines are now run under the board, and our VCC lines are run on the top of the board. We also had to add additional pins for the sensors. Each sensor needed a dedicated 5-volt VCC pin and a common ground pin with the rest of the components. Another major improvement to the PCB was the removal of our second H-bridge driver that controlled the step motor. The step motors that we're using require high currents and was pulling that high current from a large voltage source. This caused additional stress to our design, and after testing several alternatives on the mechanical engineering team's cars, we ultimately decided to have the step motor controlled by a separate commercial off-the-shelf product, the TB6600, due to reliability concerns. The H-bridge driver that we did leave on the board needed additional resistors added for current sensing to determine how much current to output to each of the motors it controls. This was missing in our original design, but was documented in the datasheet. The last thing we added was additional LEDs to the output pins of the microcontroller for troubleshooting and determining that our logic is working correctly.
As you can see here, we have the hardware of the some of the one of the Go Baby Go cars kind of set up. In the middle here is kind of the full setup of the car. As you can see, there's a button on the steering wheel of the car, and then you can see one of the distance detection sensors here. Most of the electronic system, the goal is to make sure the children are safe and they don't end up messing with the electrical system. So they're placed underneath the seat of the car. This past weekend, we went out to one of the parents' house in order to test out the car. We have a video right here on the left that shows the car being remotely controlled through Bluetooth. As you can see, one of my team members moving the car reverse and moving the car forward. You'll see me about to go use the button that we've set up for this specific car, and that allows the car to move forward as well. And it's continuing to move forward. And then on the right here, we have a video of the joystick setup. We have a video of the joystick setup of the car. So the car is the wheels are moving forward, and you see the joystick moving forward as well. Uh, right now, we don't have the PCB board set up within these cars. We have the Arduino and the other electrical system set up in the car in order to make sure that everything is working the way it should. For the application progress, we have bought the domain for the web app. The domain name is gobabygocarapp.com. We've developed the login and sign up page. We have the login page right here. We've developed the landing page. So basically, once the parent logs in, they'll be able to select if they're the parent or the child. If they select the parent, they're going to go to the parent's controller page right over here. With the parent's controller page, we have a joystick that's able to move forward, reverse, left, and right. We have a connect and disconnect in order to connect to the Bluetooth, and a stop car button in order to stop the car. Here is a screen recording of my phone with how the parent controller app works. So as you see here, as you move the joystick right, left, up, and down on the top left-hand corner, you'll see it actually gives signals that says right, left, up, and down. When you click car stopped, right here, it says car is stopped. And then if you move the joystick again, that button is enabled. And then when you connect a Bluetooth, like a list of all the Bluetooth modules will come up. We specifically made it where it's only able to connect to the specific HM10 Bluetooth module. So that's why if you just click connect and that Bluetooth module isn't there, it's not going to be able to connect to anything. Features that needed to be changed with this project specifically: zero radius turns. Most of the cars that the other mechanical engineering teams were using didn't have a four-wheel drive, so it was a little bit difficult on a programming sense in order to program the cars to make those turns. Specifically, the mechanical engineering team installed caster wheels instead in order to complete this requirement, and then our code was able to seamlessly integrate with that. The Bluetooth Low Energy is not a feature with iOS web apps. So, for example, iOS Safari, iOS Chrome actually don't support Bluetooth Low Energy. So, we need to download an app called WebBLE, and we're planning to give this to the parents in order for them to access the car if they have an iPhone. And the stepper motor driver for one of the cars um, needed to be replaced mainly because it was so large and we needed more. Current in order to drive the driver. So we had to use a different motor driver than what is on our PCB board. Our remaining tasks are that we need to receive the new PSB and solder on the components. One of our team members has ordered it already and should be here by Thursday. We need to troubleshoot the Bluetooth connectivity with the application and make sure it's working seamlessly. We need to work on the flashcard page of the application, which is the children's side of the application. We need to connect all the pages of the application together. We need to also help the mechanical engineering teams with installing their electrical components. We've already helped one team. We need to go out to the other two team sites and help them set up, because the delivery date for actually handing off the cars to the parents is April 10th. So we need to make sure that everything is working before then. We want to make the app look nicer. Right now, it's kind of like bare bones. We just want to make sure the functionality is working, but we want to, before we deliver the final product, we want to make it look nicer and a little bit more user friendly. And we also need to work on a user guide for the parents in order to give them an idea of how things work, and if something goes wrong, like quick fixes for it as well. Thank you for listening.